Hello calculus students, welcome to the continuing series of videos on summation and on series. In this video I am going to just show you some properties of summation. First of all, we can talk about the cases of factoring out constants. So here we have a summation of I times k, where k is a constant. So if we were to expand this, this would be like saying 1k plus 2k plus 3k all the way up to nk. But we can then just factor out the k, and we would have 1 plus 2 plus ... plus n. So this is the equivalent of saying k times the summation from I equals 1 to n of I. Okay. So see what we did there? We have this summation of I times k, and when we work this out, expand it, factor it, and then compress it down again, what we end up with is essentially the ability to factor out a k. So if you have a constant that's part of the summation expression, you can just factor that out. Similarly here, we could do notice here I have this n and this n, but in this case n is treated as a constant within the summation. So if I were to work this out, we would get 1n plus 2n plus 3n all the way up to nn, or n squared. But then we can just factor out an n, and we end up with 1 plus 2 plus 3 plus all the way up to n. So then we can just say that this is really n times the summation, because everything in this parentheses here is a summation from I equals 1 of I to n. Okay. So we essentially are able to factor out this n as well. So this is what we mean by factoring out constants. When the constant is something given to us, or the constant is something that's part of the summation itself, the ending part of the summation, we could always factor it out. And one more nifty and useful property here is the ability to separate a summation into multiple summations. So if I were to add this up, I would get 1 plus k plus 2 plus k. So notice here k is a constant, plus 3 plus k plus n plus k. Now these parentheses I added here so that we can see each term, but mathematically and arithmetically we really don't need them. We can remove them. So we can just rewrite this as 1 plus 2 plus 3 plus ... plus n plus k plus k plus k plus k. So we're going to rip out all these k's and just regroup them, and we're going to have n k, or n terms here. So what we effectively have is this first summation, which is the summation from 1 I equals 1 to I equals n of I, plus the summation of I equals 1 to n of k. So whenever you have an addition within the summation, we can separate it into two individual summations. So this right here and our final summation is the equivalent of each other. And you can also see that this part right here, this summation of k's, that's just equal to